All right, so we're going to find all the zeros. We have a list of information that we can go through. So the first thing you want to look for, so we want to factor this out so that we can find the zeros or set it equal to 0. So first we're going to look for any greatest common factors. If it has it, use it. If not, move on. If it's x cubed, then you may be able to group it, so check for that. If it's an x squared, you have a quadratic, so you have a couple options for that. So you can do the quadratic formula. You can set it into a set of double parentheses to factor it out. Sometimes you can just set it equal to 0, right? Only true when you have quadratics. So if none of those work, is this the greatest common factor? Ooh, nope, doesn't have one. Is it an x cubed? There is an x cubed, not the highest term. Is it a quadratic? Nope. X to the 5th is my highest term. So I am forced to use the rational root theorem. Okay, so this is kind of your checklist you want to go down, right? It's the easiest way, so go easiest to hardest first. All right, so I am forced into the rational roots theorem. So with the rational roots theorem, I'm going to set up my list, all right? So here is my function, my first term, my constant. My leading coefficient here is 1. My degree is 5. All right, so I'm going to start by listing plus or minus P over Q. All right, so P is the factors of my constant. So I have an 8, so I have a 1, 2, 4, 8. Thankfully, my lead coefficient is 1. So I have a list of plus or minus 1, 2, 4, and 8. All right, so here's my list. I'm going to change that real quick. Now I need to test them. I test them with synthetic division. So I'm going to start with my 1. All right, positive 1, negative 1. So positive 1, negative 1. See if any of those give me a 0. All right, so I need to think through. All right, what do I have? X to the 5th has a 1 in front of it. There is no x to the 4th, so it needs to have a 0. X to the 3rd has a positive 1. X squared has a negative 2. X has a negative 12, and my constant is negative 8. Separate those so they don't run into each other. 1, 0, positive 1, negative 2, negative 12, negative 8. All right, synthetic. Bring down your first term, multiply. 1 times 1 is 1, combine is 1. 1 times 1 is 1, combine to get 2. 1 times 2 is 2, combine to get 0 there. 1 times 0 is 0, combine to get negative 12. And I do not get a 0. All right, not a factor. Let's use negative 1. All right, so multiply to get negative 1, combine to get negative 1, multiply to get a positive 1, get a 2, multiply here to get a negative 2, combine to get a negative 4, multiply to get a positive 4, and left with negative 8. Negative 1 times negative 8 is positive 8, and woo, I threw a party because I found my 0. So this means here that I have x equals negative 1. I have found a 0. And this information here means that I am left with, right? I'm going to write that factors out. All right, so I found one solution of x equals negative 1. And the factor that I've left here, I started with x to the 5th, so this 1 here is x to the 4th. So I have 1x to the 4th minus 1x cubed plus 2x squared minus 4x minus 8. Right, so that comes from this piece right here, my synthetic quotient. All right, so I'm going to go back up to the top. Go through my list. Is there a greatest common factor I can take out? No, so that's unfortunate. Is it an x cubed? Is it cubic? No, so I can't group. It's not quadratic, so I can't use that process. I am forced into the rational root theorem again, which is a bummer, but it's fine. We know how to do it now. So let's list. All right, 1 and 8 are still my lead coefficient and my constant, so my list is the same, so plus or minus 1, 2, 4, and 8. So positive 1 did not work, so I know that I'm not going to use that again, but negative 1 could be a double, so I do want to test that again. All right, so I'm going to test negative 1. My new coefficients are 1, negative 1, positive 2, negative 4, negative 8. So let me test that real quick. Just make sure it's not a double. Bring that down. Negative 1, negative 2, positive 2 gets me a 4. Negative 4 gets me negative 8. Oh, negative 1 times negative 8 is positive 8. And I have a double 0. So if that x value does not work, do not test it again. If the x value does work, always test it a second time because you could have a double 0. So I again have a 0 where x is negative 1. All right, so I've pulled 2 of those out, so let's see what we have left. So here is what we have left, so let's write that out. All right, so I took out another x equals negative 1. I started with an x to the 4th this time, so I'm left with 1x cubed minus 2x plus 4 minus 8 is what I have left. I'm going to make that red real quick so I know what I'm working with. All right, so that is equal to 0. Go through my list again. Is there a greatest common factor? No. Is it cubic? Yes. Can I group it? Ooh, let me put that, fix that. All right. All right, let's see if we can group it. Grouping does not always work, but do check it. All right, what can I take out of here? I can take out an x squared, and this leaves me with x minus 2. Greatest common factor here is my 4, and that leaves me, woo, with x minus 2. Great, so grouping, you're taking out greatest common factors on both sides, hoping that you end up with a matching factor. If they match, woo, you throw a party because you just made your life easier. So on the right, I have an x minus 2, and on the left, I'm going to combine these, and I have x squared plus 4. Oh, so I see a pattern here. Let's see. I have that value. That x is a positive 2. So I have 3 factors. That means I should get 2 more factors out of that x squared plus 4. This is exactly why we just talked about the sum of squares. So this piece here is x squared plus 2 squared. So I know that I can use a pattern of x plus 2i times x minus 2i, or I can set it equal to 0, either way. So this x is negative 2i, and this x is a 0 with it is positive 2i. Right? If you don't remember that pattern, remember you can set that equal to 0, so you could always do x squared plus 4 equals 0. It's a binomial, so you can set binomials equal to 0. So x squared equals negative 4. So x is plus or minus the square root of negative 4. And you would get to the exact same thing, x being plus or minus 2i. Right? So if you forget the pattern and you're set with the binomial, just set it equal to 0. All right, I needed a total of 5 zeros. I found 1, 2, 3, 4, 5. Done.